Welcome to the Head Shepherd podcast. I'm your host, Mark Ferguson, CEO here at NextGen Agri International, where we help livestock managers get the best out of their stock. Before we get started, thank you to our two fantastic sponsors for continuing to sponsor this podcast. MSD Animal Health is perhaps better known as Cooper's Animal Health in Australia and for their Allflex range across the world, with a comprehensive suite of animal health and management products. Honiger is a one-stop shop for wool harvesting and animal fibre removal. The Honiger team have a deep understanding of livestock agriculture, backed by Swiss engineering and a family business dedicated to manufacturing the best. We are grateful to our sponsors for their support, helping us bring Head Shepherd to you each week. And now it's time to get on with this week's episode. Welcome back to Head Shepherd. Before we get underway this week, just wanted to quickly remind you of the hub, hub.nextgenagri.com. It's you might have been there a while ago and found not much happening. We've now put a lot more stuff on the free side of that and committing to regularly publishing article, thought pieces, information, making sure videos go up there. The podcast is always there to listen. It's also an opportunity to ask your questions or to provide comment on what we're up to or on industry stuff and get feedback from other people in the industry. There's now a big chunk of members in there, and the more you interact with that, the better that will go. So it's a great place to get on there and ask your questions across livestock, really, and or anything that we've covered in Head Shepherd, you can definitely cover there. This week on the show, it's awesome to have Bronwyn Darlington join us. Bronwyn is a really interesting woman to chat with. She's done a lot of really cool things, but as one of those recently is being the founder of Agscent, which is a technology looking to sense molecules in the breath of animals. That started out chasing pregnancy testing, so diagnosing pregnancy in cattle from capturing breath and testing for whatever molecules they're chasing in the breath of a pregnant cow, and also now evolving into methane and looking to measure methane a lot more quickly and easily in different scenarios. So, and beyond that, who knows what they'll be able to sense. So, really interesting technology that's been going for a little while, but it's really starting to hit its strap. So, I think you'll enjoy this chat with Bronwyn. Welcome, Bronwyn Darlington, to Head Shepherd.
Thank you very much for having me.
Great to have you here. Before we're here to talk about Agscent, really, but as I was doing a little bit of stalking, I was intrigued to have a look at some of the other things you've got up to, so I thought we might start there. Yeah, I'd love to learn more about some of the other things you get involved with. So firstly, talk me through the Inventing the Future program that you co-founded at Sydney Uni.
Well, when I first went to Sydney Uni to do my PhD, they realised that I had a background in entrepreneurship and in business. And so one of the things we were looking at, I was running the startup program, the entrepreneurship program in the Master of Commerce. And one of the frustrations I had was that we seemed to be trying to invent solutions that were in silos. And I'd met an amazing physicist at Sydney University, Professor Marianne Large, and we were talking about how the future has such big and nasty problems. We needed to find ways of getting PhD students to collaborate across the university, but try and do it in a way that wasn't the same 3-year spin out, but how could we pressure test some of the biggest changes that were necessary? So Inventing the Future was a program for PhD students over one semester where they had teams that came from design, business, engineering, and science, and that they had to take on really big, nasty issues and problems and actually invent a solution that they worked together to prototype within one semester. So out of that came new satellite systems for identifying crop variation, new abilities to use AI to map new rare earth minerals. But it was a really great opportunity to help those who were trying to do technical solutions to match that with how a product could be designed for actual use and the business case that had to be built in from the very beginning. So that's what Inventing the Future was. It's gone on to other iterations now. My PhD finished and I moved on to other areas of disruption and, of course, Agscent.
Yeah, excellent. So it sounds like a hackathon on steroids.
It was really. It was a hackathon on steroids, and the whole requirement was to actually prototype a product, which was really exciting.
Yeah, cool. So you also lecture in disruptive innovation, and it'd be A, explain that for the audience, and B, what does that involve these days?
Yes. So my area of expertise is really looking at the complex systems that interact as far as technology is concerned to come together to create series or stage disruption. What that means is that many of the technologies that we look at in a linear fashion, such as wireless, internet, molecular biology breakthroughs in areas, actually the major disruptions come when they combine. So the disruptive innovation is to look at not just what is an iterative response, but I talk about it, what is life going to be like if you were actually standing on the horizon in 10 years and looking back? What technologies would you be surrounded by? If everything went at the pace that it is actually developing, what would that view disrupt? And then the students are tasked, this is part of the Global Executive MBA program, to map that back rather than looking at what are the known steps to take to move to the future. Let's blow that right up. Let's look at what disruption would truly look like. Because if you think about when Uber came along and why it was so disruptive, it was a combination of so many factors, including political and economic factors at the time. The same with Airbnb. So my area for that is really challenging people to look a long way further out and realize that if you thought about what your mobile phone was 20 years ago or 10 years ago, project that out for another 10 years and think of what else that would change. What major disruptions will that cause? And then the task is to build the bridge back.
Yeah, I guess that's something that us humans aren't amazing at, is trying to, like, we can see the near term, but seeing that further out horizon and trying to predict. We're very good at under-predicting, or sort of, under-predicting sometimes and over-predicting other times. But yeah, that's obviously a time of the world that, as well, change is happening at an ever-increasing rate, and some of the stats around what the next 100 years look like can be exciting or scary, depending on which way you look at it. You're also the chair of Environmental Defenders Office and MD of Minimal Footprint Company. Can you talk us through what those two organisations get up to?
Well, I'll start with the easier one first. Minimal Footprint Company was something that I developed particularly many years ago, so it's been around a long time, to support the translation of the work that I had done in sustainability and sustainable supply chains into action. So it's really a consulting arm, but it has allowed me occasionally to speak on different topics, but particularly that relate to the minimal environmental footprint that any supply chain can deliver or new product deliver into the market. And because I have a long history in industry and I've been in many industries, that's been sort of a legacy company that has allowed me to focus on that side of that sort of swimming lane of my career. But the most exciting one really is Environmental Defenders Office. I'm a passionate believer that the public interest is underrepresented in decision-making, particularly to do with the environment. Private interest really does reign. It influences political decisions. But where it really the rubber hits the road is when the law comes into it. The law is designed as part of our democracy to ensure that we have rules and regulations and systems that mean that all of us as citizens of whatever country that has a democracy has frameworks in place to protect what matters most to us. And at the moment, the environment and the impact of environmental degradation is really being skewed into the private interest, and private interest is overwhelming our desperate need to manage climate change, our need to support primary producers in their adaptation to a new world of climate influence, and even things like biodiversity loss. So as the chair of that organisation, which is over 100 lawyers and scientists, my role is really to ensure that we have the environment and the public has the most robust voice and representation in the courts. Because if you're trying to rewild an area, or you're trying to make a transition to a more environmental friendly way of existing in regional Australia, or an Indigenous group that is being really challenged to be able to continue their custodial practices of protecting the environment by a development, the law should be the benchmark for which things are decided. And we need the best representation for everyone in society, not just the wealthy companies who are able to hire the high-flying lawyers.
Excellent. So you're clearly pretty busy, but somehow you've found time to manage, or found and manage Agscent, or develop the Agscent business. Obviously, entrepreneurial types, I mean, you would have had lots of different opportunities to start businesses on different technologies, I'm sure. So what was the inspiration to start this particular one?
It's really a mixture of all those things. So there was a time when, particularly with the global executive MBA program. So we go to the US. I take students to the US each year, and we work with UCLA for a week looking at where disruption's coming from an academic and leading thinking point of view, and then go and actually help students get under the hood of where the new technologies are and what's coming next, and realizing that there's been some substantial breakthroughs in medical diagnostic technologies. Our ability to understand algorithms and create neural network algorithms was becoming more secure, and realizing that many of the areas of progress were now much more SpaceX and NASA than one or the other. So the collaboration approach is really shifting. Take me back to the cattle yards, where I live on a 5,000-acre property in the southern tablelands of New South Wales. And we're in the cattle yards again with the vet preg-testing cows the same way we've done since pretty much the pyramids. And I'm absolutely struck by how our sector in livestock has been so hamstrung by our inability to get the benefits that, say, cropping gets with robotics, that other sectors are getting with new technologies. And I wanted to put those two pieces together to go, look, if we can look into the breath of a human now and identify lung cancer, why can't I look into a breath of a cow? They're voluntarily giving it to me every single day, and be able to see what we could see there. And for us, we're a breeding property. We have about 1,000 cows, about 15,000 sheep. We make money every live animal we have sold. So reproduction is a core of profitability. We can't get the manning that we wanted. So we need to use tools, and we need to use things that give us the right data point at the right moment so we can make a better decision. So I started reproduction, and then obviously it's now got broader. But it's absorbed me because it's so exciting as much as anything, and I love inventing things.
Cool. Excellent. So I think it seems obvious what it does from the name of the company. It obviously senses breath or odors in cows is where you focus, and with the purpose of gathering data or making decisions. So, I guess talk us through those different use cases. Obviously started off in pregnancy diagnosis and into methane, but I'm sure there's other things you're thinking.
Oh, absolutely. Well, when I started this, it was prior to COVID. So when I would talk about saying, oh, here's a bag of breath, inside this bag of breath, it's amazing what we see when we look at it with the same tools that they look at for human breath analysis or molecular biology. We call it really breathomics as much as anything. And I go, look, I can see all sorts of things here. We're seeing biomarkers for pregnancy. We're seeing methanogenic molecules. We're seeing disease biomarkers. But let's start with being able to make sure that we can actually collect a sample in our environments, which is with animals. And for me, it was easier to start with cows because we have so many of them. And I really could ring the farm manager and say, I've got a new idea. Can we just bring 60 head in? And I just want to play around for a little while. And so what that meant was I invented a technology that could collect an end tidal, like the rich biological sample from a cow. And surprisingly, I didn't know it, every cow breathes differently. Some hold their breath, some breathe very heavily, some just recycle air. Heifers, I don't know, I think heifers can just stand there and they must absorb it through their ears. I've no idea, but they almost don't breathe. And so I had to first secure the sample, and because we'd be taking samples at one point we were surrounded by bushfires. Then it was this high pollen, and it'd be 42 degrees, and we're at elevation, so it could be -5 or -8 degrees. So that was the first thing. But by being able to collect breath so robustly and so precisely for any animal, so it calibrates to any breath, it meant that we could do cows, and now that gives a platform for other things. But once we started looking at it, COVID sort of came along. I didn't seem like such a crazy person thinking that we could look at breath, because now we were all aware that breath is serious business. And that's meant that I started to look at what other decisions that are made in our sector that are really important, and methane is one. So the transition to looking at methane was really, again, coming to data points. I was really aware that, and I'll just put it back to, this is often very self-referential, because as primary producers, I felt that our perspective is often not included nearly enough in how this practically needs to work. We're on the front line of climate change. So there was no need in my mind to say, look, we should be doing this. What I really struggled with was the business case for methane abatement, until I realised from a biological point of view that an efficient cow that has less methane is efficient in other ways that relate to productivity. So now you're starting to talk my language. And rather than, I know we can't seaweed our way out of this. I know that there is a lot of inputs and support that we're going to need, but I'm big on measurement. And if I'm going to start with something, one, I need to be able to measure my own animals first. The next is I'm going to use tools that I already have in my hand. And the first step is genetics. We're breeders, so genetics is a big thing. And the second is feed. If feed is such a substantial input factor for methane, it's also for weight gain, for early ability to sell the animal if you can increase its weight. So I wanted to put those factors together because I could change more what I sow in the paddock for the same price than spending $1 a day on an input factor. But the first thing was I had to be able to measure it myself. And I didn't have any more labor. So rather than use the sensors that I developed for pregnancy with NASA, I looked for the same idea, that is sensor technology and other technology from other sectors, and put together a unit that could be hands-off, automatically providing data, but giving me as the farmer the data, not a researcher, just a researcher. The researchers, not just because researchers are just researchers, but give it to the research community. We need to give it to the practitioners because then I can make better decisions. So that was where we've created a sensor unit for methane, and we've done that in a way which can be embedded in infrastructure. And we're progressively working through that pathway because what we need to manage climate is accurate, ongoing and continuous measurement of the factor that we can control, and that's methane. So it should be in robotic dairies. So we have a system that you could put in robotic dairies. We're developing cheaper versions of this in partnerships with Macquarie University in Australia to be able to have this. It's in feed troughs so that you can continually understand what's happening with the input factors that you have control over prior to having to spend more money with other input factors, which will be important, but don't actually solve the problem for India, for example. It's all extensive grazing. They have the largest cattle herd in the world, but they're not going to be able to deal with inputs that same way. So looking at from a holistic system point of view and developing technologies that give those who have to make the behaviour change the data when they need to make that change.
It makes good sense. And yeah, I guess that's probably where I went wrong about 15 years ago, I reckon, where like I just didn't see this day where you could sense methane the same as we could. So back then we had no technology that does your sort of stuff, and so we should have trusted the fact that it would turn up and bred on anyway, because we were certainly 2009 I think we started measuring and trying to breed in that direction, but lost our way. But anyway, that's all good.
Yeah, I was just going to say that's coming back. This is this thing about I think we have to recognise the journey that we're taking to the future is actually quite circular at times, where we have to circle back and go, look, that might not have worked then, but it will now. And the lessons you learnt then still need to be applied now. And I think that's where genetics is going to be a key factor.
Yeah, and it's so true about circular nature or spinning wheels, or there's no linear direction of innovation. That's for sure. She's a rough bumpy road. Obviously, the partnership with Optiway makes good sense. Bill Mitchell would have been on the show a few weeks before you, I think, and but obviously that's a technology that gets cows close proximity to a sensor where you could measure things in the paddock.
Yes, absolutely, and that's really a platform for us to be able to look at what are the decisions, again, that people can make, that we can invent a sensor technology to combine with what we're doing now. The advantage of the Optiway is that you're getting more than one data point. You're already getting weight and you're getting their ear tag so you can create an individual animal profile. That's very important for methane and it's also important for any other diagnostics. So working with Bill at Optiway has been wonderful. We sort of joke about we're really two farmers that have played with technology to solve actual problems that we actually have. And being able to do that means we just have this different perspective of how this whole thing should work. The holy grail really for people like us is to be able to make sure that the feed that we're growing, the feedstock that we're growing, is increasing the weight of animals, that we don't keep bringing them into the yards because they lose weight every time we do, and that we can manage the market expectation, supply chain expectation of both of those factors. And one is of methane and the other is obviously of weight gain and cattle scores and fat contribution, etc. So working with Bill means that we're now looking at other measurements because the system does work very effectively. It does compare very well in independent studies to other methods of methane measurement. high correlations, and to look at things like heat stress in the north of Australia, in extensive grazing circumstances. Climate change is making the temperatures really awful and animals are being highly affected. Well, we actually think we can, in something like the Optiway, add additional sensors that, well, yes, they could do methane, but in circumstances, heat stress is really important to be able to utilise a system that Bill's developed, which communicates via satellite or mobile systems, the data back to somewhere else that someone can make a better decision.
Yeah, awesome. The first thing that caught my attention around Agscent was the concept of early pregnancy diagnosis, and I think I'm right in saying that you can pick it up very early in pregnancy. You'll pick up if a cow is pregnant from AI or so if it's handy enough to the yards, you'll be able to diagnose pregnancy from simply capturing some breath.
So when I first started looking at this, we would take breath 10 days before we would do artificial insemination. And that's at the first point of synchronization, and then 2 days before, and then on the day of AI. And the first year we did every 7 days for the first 20 weeks. And then the second year we did every 10 days. And we started to see this interesting pattern that we didn't know we'd see. And that was this early spike around day 16 to 18 of very different molecules in breath. And what we see, if you can think about it in a way from a human point of view, whenever you breathe out, the lungs are emitting trace elements of what's come from the blood. So biologically, what we had to do was map the molecular biology really of the blood and then transpiration and respiration to be able to what we could see in breath. And we found that there are various times across pregnancy for cattle, and we know for sheep and other animals, because it's sort of a mammalian function, that there are peak dates when there is biological sort of like high points. And early on with cattle, that is one. So that's the first point of fetal recognition, that we also now have a whole pile of data but have not had the time or money to develop from what we have is a vaginal probe. Because I was really concerned at the beginning of what if we're misattributing what we're seeing in breath to think it's pregnancy, and what if it's something else? And so we correlated the two, where we can get the molecules that come from the vagina, uterus, and cervix that change extremely early in pregnancy, and then can track that through, because we're also looking at various reproductive diseases. So what we found from a biology point of view was a clear molecular blueprint right across pregnancy where there are particular dates that there is particular changes. So early on, it's about elongation and replication of cells. Then as it travels through to the uterus, you've got embedding in the uterus. Then you've got securing that little fetus that has a print. Then you really have towards the last trimester when the poor mum cow is being sacrificed for the calf. So her nutrition drops and there's other factors that drop. So when we were able to do this, we started to then look at our method of how we would apply that method to other things like disease detection, to other kinds of animal biology, and then to look further afield. So in the first trials we did with some of our sheep was to look at what we would say as a producer, again, the holy grail, singles, empties, and singles, twins, and empties. And while we haven't been able to be as fast as a scanner, though we're getting pretty fast now it takes only about 10 seconds now to do the diagnostic, and then it's about 10 seconds to collect the breath. What you can do is right through pregnancy. So from an operator point of view, the aim is to go, well, what is the operating mode of whichever animal system, and how can we apply this technology to create a breakthrough where you can do this when you need to and get the information that helps you make that decision. And for us with sheep, and certainly New Zealand's big on the sheep, what we often do is we scan at a certain point in time because there is only a window for scanning. Yeah. And then something happens. And we really need to be able to have a greater visibility over what our actual lambing rates will be. And we'd like to think that the technologies it develops will really help with that.
Excellent. So that's out and about now, like you're marketing that as a pregnancy diagnosis tool or in cattle, or not yet?
Well, the methane sensing technology is out in the market now, and we're just raising funds to be able to go to manufacture for the pregnancy product, starting with cattle.
Cool.
Because we have we're using NASA technology, we have had to replicate all the NASA results, and we're not really taking anyone else's technology from anywhere. Everything we've done is our own, with the exception of the license for the tiny materials from NASA that go on the chip that actually either attract or repel the molecules in breath that relate to pregnancy and now disease. So we are just raising funds to be able to go to manufacture with the expectation that we'll be in the market before the end of the year.
Excellent. You clearly spent a lot of time thinking about and creating the future. Where do you think technology will take us? Like if we are standing on a 15-year horizon, what are we looking back at?
Actually, I think it'll be less than 15 years. My view is that within the next 5 to 8 years, what will occur is that rather than us have to go to livestock and handle livestock to have diagnostics and screening for various diseases and for pregnancy, etc., this will be the technology that's embedded in infrastructure. Yes, for pregnancy at the moment, we need to end tidal breath because it's such a fine parts per billion system. But we will be able to know so much from an individual animal point of view that we can maximise the yield from animals and minimise the number of animals in the landscape. We'll only be having to manage animals that are managed in a way that we will be much happier with, because we will know more about their worlds and be able to improve those demonstrably. I think we will also be transitioning to alternate proteins in a way that will be harmonious in the way that we actually have our whole sector. I think they will blur. But from a technology point of view, sensors will bring information to us and they will do that very holistically, and it will be seamless and it will be much cheaper. Now, when you go out anywhere, you get in your car, you've got about 12 cameras on your car. It helps assist you in reversing. That's the world that we're going to move into.
Cool. Looking forward to it. So the final question we've got is one we've been asking at every show lately, and that's, what's the last thing you changed your mind about?
Well, I must admit, it was probably what I was going to eat for breakfast, because I suddenly realised that where I'm staying has no cereal. So I'm like, oh gosh, I've got to go out now. Oh no, I have to make a decision about breakfast. What am I going to do?
I was hoping for something more profound than, but yeah.
Oh no, okay, I'll have to think of something new. From a business point of view, I guess you're really asking from a business or farm point of view of what we've changed our mind about. And you know what? I'm really struggling with that question. With that question.
That's what it's there for.
Yeah. To make it really.
You can.
You know what I have doing? So the thing I have changed my mind about as far as Agscent is concerned is which levers we will push in which order. And the methane problem is in the hands of much bigger players, and they take longer to make decisions, but the decisions that they will make will be more impacting for our sector. So while I designed the system to be something that provides individual farmers with the answer, what I've changed in my approach is to actually work with the major supermarkets, those further up the high chain for whom the data value to the market is higher, and I believe their moral responsibility to the sector is undercooked. They need to be helping us adapt to give them the data that they need to demonstrate that they are going to meet the climate targets. So have I changed my mind on something? I think I modified my view that is where the power needs to be used, but I will continue to make sure the technology absolutely delivers the right answer that's usable by those who need to make the change at the coalface, so to speak, at the cattle yards.
Excellent. And you very much just justified the value of asking that question, because you get those sort of insights. That's awesome. Yeah. Excellent. Well, thanks very much for your time, Bronwyn. It's fantastic to see someone of your knowledge of the sector and your passion for innovation all tied up in the same person. That's very cool, and almost feel bad that I haven't actually bumped into you before. But yeah, it's awesome, because I think the power of people knowing what's out there is, like, most of us, you can live in your day-to-day and not actually know what's possible, so you never innovate in a way that, because you just sit there thinking that, well, that's impossible. So, but once people know what technologies are coming, you can farmers are amazing at putting them into place. So it's great to have you out there and passionate about our sector.
Thank you. And I think the other thing, just to finish on, is that What I really love is the fact that this is inspiring young people to come from outside our sector in. And our office is full of people who have come from molecular biology, from human sciences, from space technologies, and are now finding that agriculture and livestock, this is the coolest place to be. That is where we need to keep driving in because that's the change we need.
Couldn't agree more. That's awesome. Thanks, Bronwyn.
Thanks so much. Nice to speak with you. Thanks, Mark.
Same. Thank you. Thanks again to Heinegger, who are proud world leaders in the manufacturing and supply of professional sheep shearing and clipping equipment. Thank you to MNSD Animal Health and Norflex Livestock Intelligence. They offer an extensive livestock product portfolio focused on animal health management, all backed up by exceptional service. We thank both of these companies for their ongoing support of the Head Shepherd podcast.